situated tomorrow in a pretty convenient location to create some severe weather. They're going to be really close to a surface front and a surface low that's pushing into the region. So we can go ahead and take a look at those conditions for tomorrow to see what the atmosphere is showing in a place like Omaha tomorrow night. So let's go ahead and pull up the vertical profile of shear. We always talk about wind shear as a critical factor to create organized thunderstorms. If you look at the shear for tomorrow, look at the change in direction with these wind vectors as we increase with height. As I turn this around, you can see in the lower levels of the atmosphere, the winds in this case blow from left to right. But as you go up in the atmosphere, a complete change in direction. Now they're blowing from this side of the area right through the camera. So that's a lot of rotation that's going to be present in the atmosphere tomorrow. So that's going to be key to creating some organized and potential supercell thunderstorms in Omaha tomorrow night. Now, if we look at the instability, notice these blue colors as we look down towards the surface here, up to about 10,000 feet. A very strong cap present in the atmosphere tomorrow, or forecast to be present in the atmosphere tomorrow, which may hold things down initially. Storms are going to have to break through this cap to be able to access the instability that's lofted up in the atmosphere. Those red colors show you where the most unstable air is, and that's upwards of about 15 to 20,000 feet. So that's going to be key. Definitely need to break through that before we get the storms going. But we've got a lot of dry air that's going to be present in the upper levels of the atmosphere. It's moist down low, but then notice that dry air starts creeping in right around 5,000 feet and upwards. This may actually enhance the severe threat tomorrow because this dry air can create very strong downdrafts and may also create the potential for some large hail. So keep that in mind. We've got all potential threats then in play for tomorrow. Now here's a look at that surface feature. Notice that Omaha right here is right along that surface front. That surface front's going to act as the trigger point for storms as that moisture is lifted up and over that front. So Alex, Omaha could be in for a busy night.
It's definitely changing, that for sure. And what's going on with the Kilauea volcano is basically lava is draining out of this like a bathtub, okay? So Dr. Navarro with us here, a little chalk talk, to talk about why water in this regard could be a really bad thing for the Kilauea volcano.
Yeah, it might add to the explosive nature of the next eruption of this system because steam is actually really powerful when you take into account the pressure differences between two things. So this all has to do with something called the lava lake. It's the area in the crater near the base of the volcano that gets evacuated.
And we were looking at Kilauea. It can come out the top. It also has all these pipes that come off it. We're talking about these fissures that eventually come up to the surface, right? And so it's draining in multiple places. So basically what we've done is we've taken away a whole bunch of this, right? And we've drained it down below the water level, in essence, and that's a bad thing.
Yes. So once you get down to this level, this is when you start to become very vulnerable because now that area that used to be surrounded by lava is weak, and it creates potential breakoffs of the rock in the area, which could combine and basically close up this pipe here, right? But then now the groundwater that's in this area begins interacting with the very hot molten rock that's around because this is incredibly hot. I mean, we're talking thousands of degrees Fahrenheit, right? So then at this case, you get all this steam that begins to build up from the evaporation of that water. But then that steam is in a very narrow area, and then eventually it's like popping the lid off of a pressure cooker, right? It's going to absolutely explode.
So what you're likely to see out of that explosion is not necessarily lava so much as all the rock and debris that's filled up that conduit.
Right. And, we were just talking about this in the break. This ash cloud here, so once you get that explosion, of course, all of that pressure releases. You get that huge expanse of cloud and ash. That ash cloud gets lofted way up into the atmosphere, Mike. You said about 20,000 feet.
20,000 feet they're anticipating it could happen. The thing is, what they're doing is they're monitoring how much deflation in essence, how much deformation is happening, how much is this area sinking around it to give them some idea of, okay, how much is falling in and how much are we going to see come out?
Right, right. Obviously, the more rock that we get broken off, the more that gets lofted in here. I mean, the more potential we have to create some big issues down the road.
The geologists saying it could happen at any time.
Yeah.
So they're worried.
No, it's
rightfully so.
Right, it's terrifying, Alex. I mean, when you think about that, I mean, to think there are people living nearby this place. I
wouldn't want to be there. And when we look at U.S. volcanoes since 1784, the deadliest one was Kilauea, followed by Mount St. Helens.
Right. I mean, by far. You look at these 421 deaths, unfortunately, with this, but there are numerous other volcanoes in the atmosphere. I was surprised in the United States, I should say. I was surprised to see Yellowstone down here, but I guess guess, Yellowstone has that super volcano that's underneath the ground. So potentially that just because it hasn't erupted, let's hope that never happens.
Right, absolutely.
Yeah, if you don't know what I'm talking about, look that up because that's pretty terrifying.
Or don't if you want to sleep tonight.
Right, yeah, or not, right? But there are a number of other volcanoes here in the U.S. that have caused some issues, places in California, of course, Mount Hood in Oregon. So it just gives you an idea. I mean, we live really close to these structures, and you think, should I be worried about this? I mean, yes, they don't erupt, very frequently, sometimes on the time scales of tens of thousands of years, but it's still a threat.
It still can happen. And, Mike, what we hear from the folks there in Hawaii is you've got to respect Mother Nature. And, in the end, that's where the power is.